This is the video for Mod 9 Lesson 4, Similarity in Right Triangles. The goal for this is going to be to apply properties of the geometric mean to find different lengths for right triangles, and specifically when we have an altitude that is drawn within a right triangle. For these problems, we're going to look at a very specific example where we have a right triangle and an altitude that's drawn within that right triangle. So in order to find these different values, we're going to be using the geometric mean, and really it's going to be setting up a proportion using those similar right triangles. So really what we find is that we're going to set up a proportion, and we can find our altitude using the relationship x squared equals a times b, or a over x equals x over b. The altitude to the hypotenuse of a right triangle divides the triangle, so we have two similar right triangles. So what that means is, when I look at this triangle, I have the bigger for triangle ABC. C is a right angle. We have these two acute angles, angle A and angle B, and we drew an altitude within that triangle. So what happens is when we break apart these different triangles, I have my larger triangle that I'm calling ACB. And I have like the 1 tick mark and the 2 tick marks. I have this triangle that's on the upper part, which is also a right triangle. So ADC, and if I carry those same tick marks, it has a right angle and that 1 tick mark for A. So actually we know that this angle ACD is the same as little b. And then we can look at that lower triangle. This is 2 tick marks. We know that this has to match with the 1 tick mark. And so we really end up having 3 similar right triangles, and we can use and set up proportions to solve missing pieces. For these two examples, a lot of different ways that you can kind of set up the problem. The easiest way is, I always like to think you start with the right angle for the big triangle. And really any segment that comes from that right angle is going to end up getting squared, right? So if I look at it, I see I have x is an altitude that's coming from that right angle. So what we're basically going to do is we're going to take x and square it. And that's going to be the same as the smaller segments that make up the hypotenuse, right? So if you think about, you're coming straight down from that right angle or straight up, and what's happening then is I'm squaring the x, and I'm saying that's the same as 64 times 36. So it's the same as the two smaller segments that make up the hypotenuse. If I go ahead and solve this out now, I have x squared is equal to 2,304. And then I'm going to square root both sides. I'm not going to worry about the negative answer because we're talking about length, so it has to be positive. And we're going to get that answer to be 48. So what that means is the length of the altitude is actually 48 units. I can do the same thing with the second example. So I'm going to locate the right angle for the larger triangle, which is, in this case, happens to be at the top. The 12 comes from that right angle. So when we go ahead now and write that, it's going to be the same as multiplying the two smaller segments that make the hypotenuse. So 12 squared is going to be x times 16, or 16 times x. I'm going to get 144 equals 16 times x. And then we don't have to square root because there's no x squared in the problem. It's just a linear equation. I'm going to divide by 16. And then we're going to get our length of that is going to be 9. So this segment is a length of 9. The same property holds when we're talking about the leg and the hypotenuse. We can still again use the geometric mean. The only difference is for this property, we're either solving for one of the legs, right? But we can still use those similar right triangles where we're basically squaring and then multiplying. The only difference is in the two segments, we're going to be looking at the entire segment and then breaking up a smaller piece of that hypotenuse. So in this first example, again, I'm going to locate the right angle for the big triangle. I see x comes from that. It happens to be, though, a leg. So I'm going to say x squared. And my two segments are not going to be 36 and 64. It's still going to be 36, so I'm going to do the small piece that goes with that triangle and then the entire length. So 64 and 36 is 100. So the small piece times the whole thing. So we're going to do 36 times 100. X squared equals 3600. And then when we take the square root, we're going to get x to be 60. And we're not going to use the negative. We only use the positive because it's a length. So this length here is 60. And then finally for the last one, same thing. I'm going to locate the right angle for the big triangle. Anything that comes from that is going to get squared. So 15 is going to get squared. And then I'm going to set that equal to the smaller piece that goes with this triangle here. So 9 times the entire length, which is x. So we get 225 equals 9x. And then x is equal to 25. And so our final answer, the hypotenuse, which is what we were solving for, is 25. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.